Welcome back, my dear students. Today, in our topic is elements of pulse code modulation, elements of PCM. In pulse digital modulation, in previous videos, we dealt clearly about the digital communication process. In the digital communication process, the pulse modulation, pulse digital modulation. We discussed in analog communication basically pulse modulation, the pulse modulation, pulse analog modulation, and pulse digital modulation. In pulse analog modulation, the PAM, PPM, and PWM, pulse position, pulse width, and pulse amplitude modulations are there in the analog communication. These are the under analog communication systems. We already discussed or learned in the last semester. In the present semester, the pulse digital modulation, the first modulation technique is the pulse code modulation. This is the basic block diagram of the pulse code modulation. Pulse code modulation. First of all, the analog message signal. The basic first point is the information source. Next, that is the fed to the low pass filter. Then that is fed to the sampler, quantizer, encoder. The output of the encoder is considered as PCM, pulse code modulated signal. That signal is fed to the sent to the channel. In that channels, in between these channels, I already told in the previous videos that regenerative repeater stations are there. The regenerative repeater stations, the transmitted signal reaches the receiver through these regenerative repeater stations. In the receiver section, there is a different blocks: regeneration circuit, decoder, reconstruction filter, and destination. Let us discuss in detail at the each section what happened. So first of all, we know the analog information or analog message signal, then it is fed to the low pass filter. The low pass filter eliminates the high frequencies components. We know well about this because generally the information is in the voice signal. So generally voice, and that voice signal is the voice of the human being, generally human being or any other birds, etc., etc. These signals are generally in the low frequency range. That's why here we accommodate the low pass filter. The low pass filter eliminates the high frequency composes patterns in the input analog signal, which is greater than the highest frequency of the message signal, to avoid the aliasing of the message signal. Aliasing with the overlapping or dominating. So, in order to take the input from our source, some unwanted sounds are present in the surrounding areas. That's why here we employ low pass filter. The low pass filter only allows that message signal ranges only. Other high frequency components are eliminated in this section. Then these signals are fed to the sampler. The basic block diagram of the we discussed, you just kept or keep it in mind always what is the basic elements or basic block diagram of the digital communication system. In that I said, or we discussed first stage the information source, then it is changes into the A to D. It means the analog continuous signal to discrete in nature. You don't forget in that point. So here the output of the low pass filter is an analog signal. That analog signal is fed to the sampler. The sampler is the the sampler performs the sampling. The sampling is a technique which converts the continuous signal to the sample signal. Actually here we sampled the signal. It means using the sampling technique. The sampling technique also clearly discussed in previous semesters. I think in a signals and system subject you read about this sampling theorem and sampling technique. So actually here, just wait 1 minute. Actually here this is the continuous signal. In order to the instantaneous values, this continuous signal having the instantaneous values of the original information signal. It means voice signal, for example. So here we collect, we don't collect entire signals in the digital communication. Here we collect only that points only, samples. That means we collect at the sample points, at sample points, at sample points. We collect that sample points. It means these samples are taken by us. Then, so after taking the samples, that signal will be like this. You just for example purpose. In this way, that continuous signal converted into the, in this way converted into this discrete nature. What happened in this? We take samples at the at the different time intervals. So, this is that's why here we clear state the sentence. This is the technique which helps to collect the sample data. Collect the sample data. Sorry. Sorry. We collect the sample data at instantaneous values of the message signal. The instantaneous values of the message signal is here. At that instantaneous, in that instantaneous values, we collect some points, some points, some values. That's all. That values where we taken is depend upon the sampling rate. Means the different time intervals. In the different time intervals, we take that samples. That is the time interval. That time interval and that process are we discussed in next classes clearly. What is sampling? What is the types of sampling? What is exactly happened in the sampling technique. Don't worry, we discussed it clearly in the next classes. Next, that sampler, actually, this next sampler fed to the output of the sampler is fed to the quantizer. It means in the quantizer, the quantization is happen. Quantizer is a block which performs the quantization. The quantization is a process. It creates a different levels. Simply in that samples also, in that samples. Uh, one minute. In that samples also, the data sometimes the same data will be there. The same data will be there in between these two samples also. That's why the technique is introduced called the techniques are introduced called quantization. This quantization technique is eliminates the redundant sorry for interrupt. Actually, these sampling signals, these sampled the sample information also have a same repetitive information. There is a chance in order to eliminate that repetitive information. We introduce the quantization. The quantization reduce the excessive or confining the data. Here it is a statement: quantization is the process of reducing excessive bits and confining the data. Here the bits means information. So any redundant information there in our signal that is eliminated by using this quantization. The clear idea, that clear explanation of the quantization, the clear idea and explanation of the quantization is in the further videos. So next in the next classes we discuss about the quantization and sampling techniques clearly. Okay, next. Next, encoder. Encoder is the digitization of the analog signal. And next, you just retrieve the elements of the digital communication block diagram. After the source coder, there is a channel encoder. That channel encoder, the performance of the channel encoder done this in this encoder stage. The digitization of the analog signal is done by the encoder. It means what is the discrete in nature signals, the output of the sampler or quantizer. Both the outputs are fed to the encoder. In the encoder section, the levels are further digitalized. It means these are converted in the form of streams, bit strings. Each quantization level. So each and every binary data converted into a binary code. It quantized level. It means the quantization output of the quantizer is produces the different levels, that each level designated by the binary code. Next, actually these both are the merged. The sampling and quantization is performed in the pulse code modulation level. The output is performed. The output is converted to the digital data. The regenerative or repeater section. Already we told the regenerative and the repeater sections are between the transmitter and receiver section, placing some between some distances. When the transmitter data reaches the repeater station, again it stunted the signal and then fed to the next stage. These are the two statements. The section is increase the signal strength. The point is right. The output of the channel also has one regenerative repeater circuit to compensate the signal loss and reconstruct the signal. This is the main purpose already we discussed. The decoder is the reverse procedure of the encoder. Received data at the receiver section, the bit streams are further decoded as a general band repeats the original signal in order to incorporate in order to retrieve in order to make our original signal. The reverse process of the transmitter section happen here in the receiver section. Finally, reconstruction filter is there. Reconstruction filter also a low pass filter generally, because our original message signal is a low frequency signal. So after digital to analog conversion, at the in the receiver section, after the receiving the signal at a decoder, after the decoder section coming to receiver section, regeneration circuit means the decoder after reconstruction filter. After the decoding the after the after decoding the signals, that that data fed to the reconstruction filter. It means the low pass filter, so low components, the output of the low components, the output of the low frequency signals, then fed to the destination. It means the actual our message signals. Here the clear idea, after the digital to analog conversion is done by the regenerative circuit and the decoder, the low pass filter is employed called a reconstruction filter. Here the reconstruction filter is a low pass filter to get back the original signal. Hence the pulse code modulator circuit is digitizes the given analog signal codes and samples it and then transmits an analog form. So finally we conclude that the pulse code modulation technique, first of all, analog signal converted into the digital form. It means the continuous signal converted into the discrete in nature using the sampling. Next, in order to reduce the repetitive messages, that's why using we quantization, the both sampling and quantization occur, then it is encoded. That encoded data further converted into a analog form. That analog signals are transmitted through the our channel. In between these transmit and receiver section, there is a repeater sections to send the signal at the receiver side. Finally, received data converted to again digital to analog, and that analog signal is fed to the reconstruction filter. It means low pass filter, the output of the low pass filter, smoothing by the smoothing section in the destination. There is a smoothing section. In that, our original signal is get back successfully. This is about the pulse code modulation. Next classes we discuss next topic. Thank you very much. In next classes, ready to learn about the sampling and quantization clearly. Before coming that, you just revise or review your old notes or textbooks about the sampling. You already learned about the sampling in the some other subject, signals and systems. Thank you very much.